Hello mortals. For most of human history, technology meant rubbing pieces of wood against each other and creating fire. Nowadays, it ranges from manipulating matter at its smallest scale and training artificial neural networks that simulate the human brain, all in order to display a meme on your phone at 3 a.m. The device you are watching this video on has a processor containing billions of tiny things on the scale of a few hundred atoms that we call transistors. Essentially, they are hyperfast super switches that turn on and off billions of times every second and help process whatever it is you want to do, from calculating 1 plus 1 to listening to science files' pleasant voice speaking to you right now. Transistors work thanks to this branch of physics you've definitely never heard of before, called quantum mechanics. And not just transistors, but also GPS, lasers, MRI, and even the internet itself. But even with all of that, the applications of quantum physics in everyday life are just in their infancy. So let's take a look at what else the near and far future holds for us in the context of quantum technologies. And for that, let's brush over the basics. The fundamentals of quantum mechanics lie in the principle that a particle's state properties can never be predicted with absolute certainty, but only with a range of probabilities for each possible state. As a result, this particle is not in any given state, but rather in all states at once until observed, illustrated with the world-renowned Schrödinger's cat. And the entire branch of quantum computing is built on this exact principle. Instead of regular 0 or 1 bits, quantum computing uses quantum bits, which are individual photons that are in a superposition, meaning these qubits can be both 0 and 1 at the same time. Just like a coin that continuously spins and holds the possibility of being either heads or tails until stopped and looked at, a quantum property cannot be observed without changing or disturbing it. But why use fancy qubits when the regular ones work just fine? Because they come with a set of pretty neat advantages. As mentioned, qubits are particles that can represent the values 0, 1, or a superposition of both at the same time, and the information they carry is characterized by a quantum property, such as the spin of an electron, which can be up, down, or both at the same time. Qubits are whole particles and cannot be copied. While it is possible to measure a qubit and create a new one with the same properties, this does not guarantee that the state of the first qubit has not been altered during the measurement process. Essentially, nature is trying to keep the true state of a particle hidden from us, and we can use this secrecy to our advantage through a technique called quantum cryptography. Before we get there, even if understanding how quantum technology allows for secure data encryption and transmission is a tedious task, nothing is more challenging than learning a new human language using a human biological brain. However, thanks to today's sponsor Speakly, and its practical and real-life-oriented teaching method, you can become fluent in multiple languages in just a few months with just 30 minutes of learning per day. Speakly was created by two polyglots who speak 7 languages each. They conducted extensive research on thousands of language learners for 6 years and developed a unique method that focuses on teaching words and sentences that are relevant to real-life situations. Everything taught is stripped down to the essentials and is designed to be practical and useful in actual conversations, resulting in you mastering the language up to 5 times as quickly as you would normally. Speakly's fluid and engaging platform offers creative writing, listening, and comprehension exercises, as well as song recommendations to make learning a new language fun. Get a 7-day free trial and a 60% discount on an annual subscription by downloading the Speakly app on Android or iOS through the link in the description. Start the new year by treating your brain and learning a new language with Speakly. Back to our video. Quantum cryptography is a method of transmitting secure data over optical fiber using qubits rather than classical bits. It relies on the quantum properties of these qubits, which are photons with polarizations in our case, to secure the transmitted information. A photon can have 4 states of polarization: horizontal, vertical, diagonal to the right, or diagonal to the left. Horizontal and diagonal to the right polarized photons could represent qubits with the value of 1, while the vertical and diagonal to the left ones, the value 0. If a photon with horizontal or vertical polarization is measured using a rectilinear filter, it will be measured correctly without changing its value, similar to measuring a diagonal photon with a diagonal filter. When a rectilinear photon, horizontal or vertical, is measured with a diagonal filter, the photon's polarization will become diagonal, either to the right or to the left. If the sender wants to transmit a series of zeros and ones, They will polarize the photons accordingly, but they will randomly choose between using rectilinear and diagonal polarizers. The receiver will also measure the polarization of the photons using a random filter for each photon. The sender and receiver will then share the scheme and filter they used for each photon, and any bits of information for which the scheme and filter do not match will be discarded. However, if an eavesdropper is intercepting the series of photons, such as the governments of the world trying to crack down on the creation of Skynet, they will not know which filters to use and will risk altering half of the photons. The receiver and sender can check the polarization of some of the qubits that were not discarded, and if the values do not match, it means that someone has modified their message, and the Skynet self-preservation article will be put to use. This key distribution protocol is called BB84 and is one of the most commonly used in quantum cryptography. Quantum entanglement, also referred to as spooky action at a distance by Einstein, is a phenomenon in quantum mechanics where two or more particles become interconnected, such that the state of one particle can immediately affect the state of the other particles, even if they are separated by very large distances. This seems to violate the principle that physical events cannot travel faster than the speed of light, which made it appear spooky to Einstein. However, now that we know that even though the information is not actually transmitted between the particles, thus no violation of causality happens, quantum entanglement can be used to enhance the security of quantum communication. One application of quantum entanglement is quantum teleportation, where information can be transferred between locations without moving the physical matter that holds it. This allows for completely unhackable quantum networking, known as device-independent quantum key distribution, which enables wireless, fully secure quantum communication. The Nobel Prize in Physics for 2022 was awarded to Alain Aspect, John Clauser, and Anton Salinger for their experiments that demonstrated the reality of quantum entanglement and their contributions to the development of quantum technology. Very recently, a paper titled "Traversable Wormhole Dynamics on a Quantum Processor" was published, which explores the connection between quantum physics and gravitational physics by examining the similarities between quantum entanglement and wormholes, with the conclusion that they are very alike, or even possibly the same phenomenon. The researchers created a quantum entangled system in Google's Sycamore quantum computer and studied the properties of information transferred through it, finding that these properties were similar to those of a theoretical wormhole. Once you put together quantum devices in a working quantum network along with some quantum cryptography and quantum entanglement, basically the entire shebang so far, you get the quantum internet. This will make the devices and networks we use today look like toys. It is significantly faster and more secure than the current internet and has numerous practical applications, including solving mathematical problems way faster, speeding up the development of medicines, and creating more advanced artificial intelligence. Qubits, which are used in these networks, allow for exponential increases in speed compared to traditional networks. The quantum internet is also expected to provide a higher level of privacy, as it is much more difficult for outside parties to intercept and access information transmitted through the network, so no more giant evil lizard corporations spying on you.
But you can never escape Skynet.
In 2020, as you might remember, the pandemic that we shall not name swept the globe and there was an urgent need for a vaccine. In the past, it has taken more than 10 years to develop vaccines, and even the fastest vaccine ever developed, the one for Ebola, took 5 years to create. In the face of a potentially catastrophic global pandemic, this is an unacceptable amount of time. To speed up the process, scientists utilized the High Performance Computing Consortium, which is a group of supercomputers at major technology companies and research labs, including NASA. These supercomputers provided a vast amount of computation power, with the HPC consortium performing calculations at a rate of 50 times the amount that would be achieved if every person on Earth did 1,000,000 calculations per second. And mind you, these aren't quantum computers, these are just current supercomputers. We're looking at increases by hundreds if not thousands of times in terms of efficiency if we were to use fully fledged quantum computers. This technology takes advantage of the inherent fragility of quantum states, which makes them very sensitive to any kind of disturbance. Their sensitivity can be harnessed to create incredibly precise instruments for measuring things like microscopy, positioning, time, and various physical phenomena such as gravity, electricity, and magnetism. Imagine having all of these powerful tools at your fingertips, even on a device smaller than your phone. It's like having a full rocket's worth of sensor equipment right in the palm of your hand. Imagine atoms bouncing around, like billiard balls. When photons encounter these atoms, there is an exchange of momentum happening there, and the photons are scattered all around, including into your eyes. This is what makes stuff visible. But if you take a bunch of really cool atoms, speaking temperature-wise, like those from a gas, and tightly pack them together, when the photons strike and the electrons in the atoms have nowhere to move due to the density, they can no longer absorb the kick and scatter the photon. Thus, the atoms become transparent. This is called Pauli blocking. And this is possible because of Pauli's exclusive principle, which states that no two electrons in an orbital can have the same quantum properties. And scientists were actually able to make real gas invisible using this exact method. Quantum technology is now slowly transitioning from only being a buzzword used in every second sci-fi movie, to an actual bedrock for the most essential technologies used by us every day. In the future, it's certain that the impact of quantum mechanics will only be amplified, ranging from nanobots manipulating the very fabric of the world, to potentially even teleportation. And with breakthroughs in artificial intelligence, it won't be long until the smarter-than-human machines will be able to utilize the full power of quantum physics to accelerate technological progress to exponential levels. If that quantum AI-dominated future will include humans is a different question, but you already know what is the least that you can do right now.